Hi, welcome to my IBM Advanced Data Science Capstone project presentation. My name is Richard Njolomba. I am a chartered accountant who has just fallen in love with data science. I'll be tackling a subject on credit card fraud detection using machine learning. So welcome to the presentation. Welcome back. The global credit card fraud was estimated at 24.6 billion in 2016 by the Nielsen report, a publication covering global payment systems. The cost could be even higher, as the estimated cost mentioned above does not include the cost to retailers, card issuers, and users. The problem is expected to increase by 10 billion in the next 3 years. The cost to individuals and retailers can be very devastating, and thus the need for banks to come up with new methods of fraud detection. The purpose of this project is to create a model that will predict fraud credit card transactions so that card users are not inconvenienced by incurring huge amounts of money resulting from fraudulent transactions. For the purposes of this project, I have chosen a dataset from ZD website. The dataset is one of Xete, an e-commerce and financial service app serving 10,000 plus customers in Uganda. This dataset includes a sample of transactions that occurred between 15th November 2018 and 15th March 2019. It's fairly a new, a recent dataset. ZD is the first data science competition platform in Africa. ZD hosts an entire data science ecosystem of scientists, engineers, and many others who are focused on solving Africa's most pressing problems. Fraud detection can be used to connect data points in order to discover potential fraudulent behavior before it actually happens. Fraudsters have become more sophisticated. Therefore, fraud detection methods used in predictive analytics have to create connections from raw data to discover which interactions would lead to fraudulent behavior. The model solution is based on two unsupervised traditional machine learning algorithms, isolation forest and local outlier factor. As per the requirement of the course, I've also used one deep learning algorithm. The technology applied include a data file in CSV format which was uploaded in Watson Studio as an object. I used Jupyter Notebook in Python to perform data loading, processing, and model training. I used Pandas data frame for data loading, data processing, and feature extraction. I used Matplotlib and Seaborn for visualization. I use scikit-learn for pre-processing, cross-validation, and visualization. I also use Keras with TensorFlow backend to train an auto-encoder neural network. The dataset is generally clean from source, so no major cleaning was required. However, the dataset is clearly imbalanced as per the visual below. More than 99.9% of the data transactions were actually valid transactions. The dataset has no missing values, but it was necessary to drop columns with no impact on the model performance. So I dropped transaction ID, batch ID, account ID, subscription ID, customer ID, and currency code. Two categorical columns needed to be transformed to numerical data. I transformed product category and provider ID. I use accuracy score and classification report from scikit-learn to feed the model. From ensemble method, I deployed two commonly used methods, isolation forest and local outlier factor, as mentioned earlier. The two methods in my opinion, were suitable in fitting imbalanced data sets. For example, isolation forest is based on the fact that anomalies are data points that are few and different. The local outlier factor algorithm is unsupervised outlier detection method, which computes the local density deviation of a given data point with respect to its neighbors. It considers as outliers samples that have a substantially lower density than their neighbors. So from this you can see that these two methods would suit our data set, which is highly imbalanced. The model evaluation gave us the following result. Isolation forest performed better than the local outlier factor. We achieved accuracy figures of 99.7% and 99.6% respectively. These results appear quite good, but when it comes to precision, recall, and F1 score, local outlier factor performed poorly. You can see from the table the precision, recall, and F1 score under local outlier factor was very poor with regards to class 1. But with regards to isolation forest, class 1, we didn't perform that badly. We had precision of 43%, recall 43%, and F1 43%. So generally speaking, isolation forest performed better than local outlier factor. With regards anomaly detection, using autoencoders, I used Keras with TensorFlow backend. I standardized, I applied standard scalar from sklearn in order to transform all the numeric data such that the distribution will have a mean of 0 and a standard deviation of 1. The main idea is to normalize the features. I split the data into training and testing sets and applied a random seed specified at the beginning of the project. Autoencoder method generally gave me my biggest challenge. The model appears not to have performed well, and the challenge appears to be perhaps in data preparation. If you look at the training loss and the validation loss scores, were way too high. The accuracy rate was up to 100% in one instance. This made my model look unreliable. If you look at the confusion matrix results, they were very, very questionable. For example, all the valid activities were predicted as fraudulent transactions. Clearly, there's much more work to be done as regards to autoencoder in this project. Generally speaking, I was very happy with my performance of in the first part of the project using isolation forest and local outlier factor. With this, thank you so much for your time and have a good day.